Welcome to 4.2. 4.2 is linear and quadratic functions. Now, except for, vertex form of quadratics, which is at the end of the section, the linear stuff is exactly the same that we've been doing already. It's not anything new, except that we're going to be using function notation instead of that mx plus b, instead of the xy. So, in the guided notes, they go over what a linear function is, graphing them, finding linear functions. I want to just talk about a few of them and then do a couple examples. So a linear function is of the form, well, a linear equation, remember, was y equals mx plus b. That was one of our linear equations. A linear function is going to be the exact same thing, except instead of y, we're using f of x now, because that's what our function notation is. So it's of the form f of x is mx plus b. That's it. Okay. So my comment to this is exactly the same as a linear equation, except we're using f of x instead of y. Okay. So this is the exact same as a linear equation, except we replaced y with f of x, and that's what all 4.1 was about, was writing stuff with function notation instead. Okay, so they have you graph. Literally all you're doing is graphing a line. I do want to do one of the 1x example. So let me get one ready. So let's look at one example type, which is find a slope and y-intercept and then graph. So this actually comes from your homework. They give you the function p of x is 3 minus 3/2 x. They want you to give slope, intercept, and then graph it. I'm going to both graph it on paper so we can practice that, and I'm going to show you how you can easily graph it in HAWX. So this is secretly y equals mx plus b, right? Secretly, except that I have a p of x instead of a y, but that's the only thing that's different. So if we rewrite this, we get y equals minus 3/2 x plus 3. And why did I write it in that form? Why did I rewrite where the x and the b were? Or just because for most students, having it in the right order makes it a little bit easier. Okay, so I write it like this. We know that the slope is the coefficient of x, and we know that the intercept is the b value, the 0b, and in that case it's the constant. Okay, so slope is m, which in this case is minus 3/2, and the y-intercept is 0b, which in this case is 3, 0, 3. Okay, now for practicing graphing, I do have a bunch of grids that I went ahead and was able to print out before we were banned from campus. So I'm going to use one of these. I uploaded them onto Blackboard so you can use them as well. So this is 1A. Okay. So if I were to do this graphing, the slope is negative 3/2, so one positive and one negative movement, and the intercept is 0, 3. So I start at 0, 3, which is here. and I'm going to move either up and left or down and right. So down is negative, right is positive, that's overall negative. And this says 3 over 2, so my y changes 3, my x changes 2. So down 1, 2, 3, right 1, 2. If I were doing this by hand, which you guys do have to do for your exam, I would go ahead and fill this in all the way. So down 1, 2, 3, right 1, 2, down 1, 2, 3, right 1, 2. And I can also move up and left. So up 1, 2, 3, left 1, 2. All right. So I get these dots and I can fill in my line. Okay. When I look at this, this does have a negative slope, and this is my p of x. Okay. Now when you go in to do this in Hawks, so you've got p of x is 3 minus 3 halves x, find the slope and the y-intercept. Okay, we just did that, so my slope is negative 3 over 2. My y-intercept is 0, 3. Okay. For the graphing, all you need is 2 points to graph the function. So because which you can't see now that I've got my screen sharing up, but since you have graphed it on paper, you can pick any of those points. So I know that I can start at 0, 3, and I can move down 3, right 2. So down 1, 2, 3, right 1, 2. All right. Done. Okay. So let's try one more of that type. So here's my second example, B. So I want to do r of x equals 3x minus 1 over 4. So same thing. Put this in, write this as y equals mx plus b. And find your m, which is your slope. So it's the coefficient on x, so it's 3 here. Your y-intercept is 0b, and in this case it's 0, negative 1/4. Now when you're going to graph, you don't have to graph using intercept and slope. There's nothing that says that you absolutely have to do that. I'm going to grab my graph, and I'm going to show you how you would graph with this fractional intercept. All right, so intercept of 0, negative 1/4, so about here-ish, and a slope of 3. So basically what I see here is that I'm a little bit below the line that's above, the horizontal line that's above. So every time I count up, I'm just going to make sure instead of going up to the next horizontal line, I'm going to just be a little bit below it. Okay, so I have a positive slope of 3, so it's 3 over 1, so up 3, right 1. So up 1, 2, 3, so instead of actually being at the horizontal line, I'm going to be down just a little bit. Oops. Should have been over 1. Forgot that part. Sorry. Up 1, 2, 3, right 1, and again I need to be below the horizontal just a smidge. Alternatively, if I'm moving down, this horizontal that's below me, I'm pretty far away from it, right? There's 3/4 of the space between my actual dot and the horizontal line. So if I move down 1, 2, 3, and left 1, I need to be have 3/4 of that space left. All right, so 1, 2, 3, left, that's all I get. Okay, so here's my line. Now, in general, I don't like giving you guys fractional intercepts to have to graph by hand because it just makes it harder, right? In a way that I don't think is adding anything to the test. So, usually I wouldn't give you such a thing. Since it's going to be randomly generated on HAWX, I'm not in control of what kinds of numbers you get. So you need to make sure that you can kind of get a graph drawn for me. All right, so here's my R of X, here's my graph. This one I just made up, so I didn't take it off of HAWX. All right. Now there's one other problem type that's for the linear functions, and I'm actually going to cover that in the next video.